I checked in my changes. As part of SQL Source Control View, you'll have the option to see a history of changes that you've made. So if I go here and say View History, this will basically show you all the commits that you've done locally to your local repository. So you can see your Git hash, the date, the name, and finally the comments and the files that are affected. And you can see what version it was previously and what it is now as part of that commit that you're looking at. So when I checked in my changes, that actually went ahead and triggered a build. Before I move on to the build side of things, there's a couple of things that I'd also like to point out. So if you're working in a dedicated model where you're working on your own database, this get latest feature becomes really handy because this is the feature that you would use to basically pull from the remote changes that have been made by other developers. And once those changes are in your local repository, then you can apply them to your actual development database. So this get latest feature is used for those scenarios. I don't need to use this now because I'm really the only person working with this database, and there's no other changes on the database from other folks. So, but if you're working in a dedicated model, then this get latest feature is what you would use. If you're in a shared model, then we provide this locking mechanism here, so you can easily lock objects. So you can say lock this object, and that will put a lock icon next to it. So whoever's using SQL Source Control, they will see that this object is locked. If they try to execute a change on the database, or on that object, it will throw an error saying that this object is locked. So if you want to see who locked it, you can go to the locking tab, and that would show you the name of the person who's locked it and the date when it was locked. And you can either speak to them, or if you know they're no longer working on it, then you can easily just unlock the selected object. All right, so now I'm going to move on to the build side of things. So again, we're using Bamboo. So if I go to my build activity, okay, you can see that our build just finished and it was successful. I'm going to walk you through the build steps that we've set up here. So we provide a plugin to Bamboo, which makes it really easy for you to interact with our build steps and configure them. So if I go to my plan configuration here, I have a total of 2 tasks from RedGate. So one is called the build, which is basically doing that validation by comparing what you have in source control against a temporary empty database and tries to build a database from scratch just to make sure that all of your objects within the database or within the copy of the database in source control are valid and that there's no syntax errors with any of the files that you have in source control. Once that database build is successful, then it goes ahead and packages up the database into a NuGet package. So this is the name of our NuGet package, and the version gets automatically assigned as the build number for that NuGet package. And you can specify where you want that temporary database to be built. So in this case, I'm doing a local DB, which is SQL Server Express, and it gets installed as part of our DLM automation component. Or you can use a specific instance of SQL Server. So for instance, if you have link servers or dependencies to other databases, then you would have to do the build on a SQL Server instance where those dependencies are available. Once the build is done, then we run a test step. So this test step relies on our SQL test tool and a couple of testing frameworks. One is called tSQL-T, which is a unit testing framework, and the other one is called SQL Cop. So if I go back to my database here, you can see there are some objects with SQL Cop schema, and some are with tSQL-T schema. So SQL Cop actually provides you with a set of tests out of box that you can use for your database. Here I'm only using a selection of those tests. There's actually a lot more SQL Cop tests that are available that you can use. But some of the ones that I'm using here, you could use SQL Cop for, enforcing coding standards, or, do some performance checks and things like that. So in this case, I have one that makes sure that there are no store procedures starting with SP_ because it's bad practice. I also have another one related to performance, so making sure that there are no store procedures with set row count. And a couple more here. So the good thing with these type of tests is that it's pure SQL, so if you want to customize any of these tests, you can simply go in and modify them and execute the changes, and that's how you would customize your SQL cop test. Now, on the other hand, T-SQL-T, which is a unit testing framework, it provides you with a set of objects here that you can use to create unit tests for your database. So, for instance, here I've got one called fake table, which enables you to create a fake table of an existing table, and I've actually used that in one of the unit tests here. So if I open up this unit test and show you what we're doing. So it's a very simple unit test. So we're testing the store procedure PRC at contact, and we're doing that by creating that fake table of our contacts table first, populating that table with some data using the PRC at contact store procedure, and making sure that the data that gets added matches the data that we're expecting. If they don't match, then this unit test will fail, and it will fail the build as a result. You can also run your tests locally using the SQL test plugin, so you can easily run SQL tests here, and you can go ahead and run whatever tests that you want to run locally on the development database. You can do that easily from within SSMS. So going back to our build log here, so this is basically the log of what we did. So validated all the objects and created our NuGet package, and also an a JUnit report of the tests that we executed on our database as part of the build. So now that the build was successful, that means we now have a NuGet package that we can use as a source of deployment going to our higher environment. So I'm going to go ahead and now try to basically deploy my changes to my next environment. I actually have both automated triggers set up for deployment to my integration environment, and manual triggers for my higher environment, such as my staging and production environment. So I'm going to switch to the deploy tab here. So we're using Bamboo for doing deployments as well. So I have a deployment project here, as you can see here, and I've got 4 environments that we'll be deploying to. You notice my integration environment already got updated with the latest release, and because I had set up an automated trigger, so every time I have a successful build, it automatically goes ahead and triggers a deployment to the integration database, and you can easily see that here. So I'm going to quickly walk you through. Actually, before doing that, I'm going to go ahead and trigger the deployment to my testing environment. So I'm going to push that same release that we automatically deploy to our integration database. And that's started deployment. And while we're waiting for that, I'm going to quickly walk you through the deployment steps that I've set up for my different environments. So again, for integration environment, that got triggered automatically. So here I've set up a trigger to automatically deploy after successful build plan. And as far as my steps, I'm using our PowerShell commandlet to first create a database release, which basically it creates a report of what differences exist between your NuGet package and your target database that you're deploying to, and that creates an HTML report where you can review the update script as well as the differences between the NuGet package and your database. And then the next step is to deploy that update script that we created as part of the previous step. So these are the 2 steps that I've configured. We actually have detailed documentation on our website and some examples of how you can configure these in Bamboo. So you can just copy the scripts from there and get up and running with it within your environment. So for my acceptance environment, however, I've got one additional step here. So here you can see I've got a step called refresh from production, because in order to make sure that my acceptance matches production, we're running a comparison between our production database and the acceptance database, mainly in terms of schema, to make sure that the schema matches before we deploy to the acceptance database. So once that's done, then I go ahead and go through the same steps as I had within my testing environment. So create the release and deploy from the database release. And for my production, I simply take the script that I generated in acceptance, because we made sure that acceptance matched production, and I execute that same script. But our process actually has a drift detection functionality built into it. So first, it makes sure that the target database to production is still at the state when we generated that script. So, and the way we do that is we keep track of, the state of your database before deployment and after deployment through scripts folder. So if I go to my testing environment, for example, and we just deployed release 10, and here you can see I have states. One is source, one is target. So source is basically the state that we want to get our target to, and the target is the state at which the target database should be at in order for this update script to successfully get executed. So what it does is that it compares this target folder to the current state of the database to make sure they match before it executes that update script. So that's how we basically detect drifts. And if there is drifts, then the deployment will fail, letting you know that the target state is no longer at the state that we have in this target folder. So I'm going to go back to my deployment report here. And you can see deployment to testing was also successful. So now I can go ahead and deploy that to my acceptance environment. And while we're doing that, I'm going to show you what that report looks like. So the report of the differences and the update script. So I'm going to go back here. Let's look at our testing environment that we just deployed to. And if you look at this report, the changes.html file will actually show you exactly what has been deployed. So here are the two changes that I made. So the PRC get contacts. As you can see, we follow a Git style here to show you how the object definition has been modified. So we replace select star from with the actual column names, and we insert a new record in the RSS feeds table. And if there's any warnings, so our compare engine would throw warnings if there's changes that could result into data loss or deployment errors. So you would see those here. In this case, we don't have any of those. And finally, the actual deployment script that got executed on my test here. And again, DLM Dashboard is a free tool and really easy to get up and running with. So if you haven't tested the tool or haven't used it, I would highly recommend you to give it a shot within your environment. So here you can see this is my blogs.redgate pipeline. Integration got updated, testing got updated, and acceptance got updated. And you can see it's actually reading the state from my build process. So if you remember, our build was at version 22. So it's saying that my integration database got updated to the version that was included as part of that build number 22 in Bamboo. And you can go in and actually review your changes. So if I go in here, you can see exactly what objects have been modified. So it shows you what type of objects. It shows you which user made those changes. And you can see the state of that object before the deployment and after. And you can easily go ahead and acknowledge your changes, and that would turn your database or your environment back to green. And you can do the same for your other environments. So there's in general two, as I said, there's two types of changes. So one is an update. So it's a state that it recognizes. In this case, it recognized the state because we sent that report from the build state, from our build to DLM Dashboard. But if it doesn't recognize a specific state, then it would switch to a drift mode. So for instance, if I go to my production database and I make a direct change to production, go ahead and make this change. And here you can see the color the tabs are colored using our SQL prompt tool. So if I'm working on a production database, it's very obvious and clear. All right, so I'm going to go back to DLM Dashboard, and now you can see my production is in drift mode because it's now changed to a state that DLM Dashboard had never seen before. And then when you go to review, you can see that, again, what type of change, who made the change, and what objects have been modified and how. And you can see here it says this change came directly from SSMS, whereas if I look at the other changes that we deployed previously, it says they came from DLM automation. So you can easily see where these changes actually came from to your higher environments. So So yeah, and you can also set up notifications here, so you can email, specific team members when there is drift on your databases, so they'd be notified. And if those changes are actually valid changes, then you would need to make sure that those changes are, reflected back on your development environment. So that way it goes into source control and it's included as part of the next release. So that way you don't override those changes when you do your next